see the second module of motion lesson. In the previous video, we learned to define the term motion, and in this session, we are going to learn scalar and vector quantities and the terms used in describing motion, that is distance and displacement in detail with examples. In physics, a quantity that can be measured in term is termed as physical quantity. I repeat, in physics, a quantity that can be measured is termed as physical quantity, and this can be categorized as scalar quantity and vector quantity. Scalar quantity is the physical quantity which has only magnitude or size. Please repeat, scalar quantity is the physical quantity which has only magnitude or size. What does magnitude mean? It is the measure or its value, or in simple words, it's the quantity. Example for scalar quantities are distance, length, mass, time, speed, work, power, energy, pressure, etc. Vector quantity is the physical quantity which has both magnitude and direction. Vector is described by its measure along with a specific direction. Examples of vector quantities are displacement, velocity, acceleration, force, weight, etc. Now, let us tabulate the differences between the scalar and the vector quantities. Scalar quantities are measured with the magnitude or its size, and vector quantity is measured by magnitude and direction. Scalar quantities change with the change in magnitude only, whereas vector quantities change with either the change in magnitude or the change in the direction. Scalar quantities can be added or subtracted using ordinary algebraic rules. These algebraic rules you might have studied in 8th standard, just like addition of two numerals. But vector quantity cannot be added or subtracted using ordinary arithmetic rules, and it needs a special geometric rules but doesn't obey algebraic rules. Scalar quantities are represented by ordinary letters, and vector quantities are represented by letters having an arrow over them which represents the direction. So vector has magnitude as well as direction, so it has an arrow over them. Now, in the previous module, we have learnt that in the definition of motion, motion of an object is perceived when its position changes continuously with respect to some stationary object. So, to locate an object, we have to choose a suitable reference point. This reference point is called origin. For example, when you plan to go to a place, you refer a landmark as a reference point. For example, you stand in front of Adiyar Ayyappan temple and you want to reach our school. What you have to do? You have to travel towards east, passing the Indian Bank, and take U-turn to reach the school. Right? Here, the temple is the point of reference or the origin. From there, you can say in which direction and how many meters you have to move to reach the destination. The simplest type of motion is the motion of a body along a straight line. If an object travels in a straight path, we call it as motion in straight line. Suppose a body starts its journey from O, which is treated as the origin or the reference point here, along a straight line OX. Refer to the figure over here. A, B, C are the positions of the object at different instants of time. Let the object go from O to C and come back to B along the same straight line. The total path covered by the object can be found as OC is equal to 80 meter. And to find the length covered by the object, we have to know that CB. So, CB can be found by OC minus OB. So, the total path or the length covered by the object is the distance travelled by the object here. So, now we have found out that here in this the total distance travelled is equal to OC plus CB. So, OC is 80 meter. From C to B it is 35 meter. So, the distance travelled by the object is 115 meter. Now, moving on to the displacement. How will you calculate the displacement? The initial position is O and the final is B. So, the displacement of the object here is, you can directly join those 2 points with a straight line which gives you the shortest possible distance, that is OB. So, OB, if you see here, it is 45 meter. So, the displacement of the object is 45 meter here. So, you can understand the definition of the distance and the displacement with the example here. The definition of the distance is the distance travelled by an object in the length of the actual path traversed by the object during motion. And distance is a scalar quantity. The direction of motion need not be specified. Distance can never be 0 or negative. And the displacement is a vector quantity and it is the shortest possible distance between the initial and the final position of the object. Can we take another example to describe distance and displacement? This is another example in which a particle travels 3 meter from a point A to B and 4 meter from point B to C, wherein AB is perpendicular to BC. You can see in the figure. Now, you are going to calculate the distance travelled by the particle. Yes, have you done? You are right. The distance travelled by the particle from A to C can be written as AC, which is equal to AB plus BC. The value we know, AB is 3 and BC is 4 meter. So, the answer is 7 meter. Have you written your answer with unit? As you have to write the physical quantities with its respective unit always. So, the distance is being the scalar quantity, you have directly added the length traversed and arrive at the total distance. Moving on to the displacement, the calculation, we already learnt that it is the shortest distance between initial and the final position. And here the initial position is A and the final position is C. So, how will the particle reach C from A? If the particle travels in the straight line from A to C, which is the shortest possible distance, right? So, we denote it by AC. So, how are we going to find this AC? You remember the Pythagoras theorem? Can you see the right angle triangle here where the angle of B is 90 degree? Can you see a 90 degree at B? So, using the Pythagoras theorem, that is, so is one side with 3 meter and BC is one side with 4 meter. So, we are going to calculate AC, which refers to the displacement here, right? That is the hypotenuse. So, AC square is equal to AB square plus BC square. So, AC square is equal to AB square is 3 square and BC square is 4 square. So, AC square is equal to 9 plus 16, which is equal to 25. So, AC square is equal to 25, AC is equal to square root of 25, which is 5. So, AC is 5 meter. So, now we can understand that the displacement in this example is 5 meter. So, now let us find the differences between the distance and displacement in the form of a tabular column. Distance is the length of the actual path covered by the object, whereas displacement is the shortest distance between initial and final position of the moving particle in a particular direction. Distance travelled by the object depends on the path followed by the object, whereas displacement does not depend on the path but depends on the depends only on the initial and final position of the object. Distance travel cannot be 0 and it is always positive. Displacement of the particle in a particular direction can be positive, negative or 0. You may need an example for these 3 cases in displacement. So, when is the displacement becomes negative? Suppose I start from a point X and move 50 meter in front and then come back moving 60 meter. It is clear that I have moved an extra 10 meter in opposite direction, which can be termed as negative displacement. When does the displacement positive? I move from point X to point Y in a straight line and I have covered the distance, and which can be termed as the positive displacement. When does the displacement become 0? When I move from point X to Y and then come back to X, this will result in 0 displacement, as the initial and final position is same. It is even possible when you travel in a circular path, right? So, 2 different physical quantities, that is distance and displacement, are used to describe the overall motion of an object and to locate its final position with respect to initial position at a given time. Automobiles are fitted with a device called odometer that shows the distance travelled by it. For example, a car is driven from Chennai to Madurai. the difference between the initial and final reading is 465 km. Now it is obvious that the distance travelled by the car is 465 km. Now, if you want to find the magnitude of displacement between Chennai and Madurai, you can find it using the road map of Tamil Nadu. This can be done as an activity. Now, can you answer this question? An object has moved through a distance, and can it have zero displacement? You think it is yes? If yes, support your answer with an example. So see you in the next video. Thank you.